Dear students, in this video we will discuss about few more important instruments in the amphibian physiology experiment. One is the myograph board with stand, simple key, short circuit key and the tuning fork. So this is the circuit. As you all know, the experimental setup has got two circuits, primary and secondary. Now in these circuits we have divided the instruments into three parts. One is the stimulating appliances, recording appliances and the miscellaneous. So first we will discuss about the keys. These keys are the part of the stimulating appliances. In the previous slide you can see we have two keys here. One is the simple key which is attached in the primary circuit, and another is the short circuit key which is attached in the secondary circuit. Then we will discuss about the myograph board which is under the section of miscellaneous instrument. So first come to the myograph board. It is a rectangular wooden board layered with wax. It has two holes which are plugged with corks which can be visualized from the undersurface of the board. The corks facilitate pinning of tissues and electrodes, and the board is layered with wax and is mounted on a stand. So what is the function of the board? We know that the nerve muscle preparation, it is mounted on it. Okay, in this way this nerve muscle preparation is mounted on this board. With the help of a pin, the knee joint is attached on the cork and the other end is attached with the threaded end is attached with the lever. Okay, so this myograph board with and the stand, what is this function? It helps in the mounting of the nerve muscle preparation. One point is important here, that this position of this lever, you can see here it is in a circle. We can show you the position of this lever. This lever is in an after loaded condition. Okay, so muscle here, actually muscle it is in a stretched position. Okay, so muscle is not lax, so that if it is not lax, so the when we apply the stimulus, the contraction will be maximum, because we know that the z lines, they are optimally separated. So the actin myosin cross bridge formation, that will be optimum in that case also. So that's why muscle is not lax, it is stretched. Okay, and while stretching we are attaching one end of this muscle, the threaded end, with this lever. Okay, so and this lever, okay, it is in the after loaded condition. Why we are calling it after loaded? In this picture you can see that there is a pin, and this pin is resting on a metallic plate. Okay, so when the muscle is in the resting state, the weight of the pin, it is not on the muscle. Muscle is not carrying the weight. Only when the muscle is stimulated and it is contracting, when it will try to lift the lever, then only it will carry the weight of this lever. Okay, so this is the after loaded condition. Okay, after loaded means only after stimulation, when the muscle is contracting, it is taking the load. But if we want to make it preloaded, what we will do, we will loosen the pin. Okay, so that it will not rest on the metallic plate. So what will happen, the weight of the lever, it will be carried by the muscle. Muscle will carry that weight before giving the stimulation and before contraction. Okay, if the muscle will carry that weight, that means it will stretch, so it is preloaded. So by attaching some weight, you can see one weight is also attached here. So if we increase the weight of this, then we can increase the preload, 10 milligram preload, 20 milligram preload, that I am stretching the muscle. And we know that if we increase the preload, okay, so that will increase the force of contraction of a skeletal muscle. So that experiment can also be performed in this experimental setup if we want to see the effect of preload on the contraction, height of contraction of the muscle. But here in while recording the SMT and other effect of temperature, what we actually do, we keep this lever in the afterloaded position. That means the pin will rest on the metallic plate. So another important point is that if we want to see the effect of temperature on the simple muscle twitch, instead of this myograph board, we will use this chamber that is known as the Lucas chamber. Why? Because here we want to apply the hot saline and the cold saline ringers, frog ringer solution like this. So if we use the myograph board, so myograph board cannot hold that saline. Okay, that's why we need a cup like structure like this. So that is the reason instead of myograph board we use the Lucas chamber only when we want to see the effect of temperature on SMT. Now come to the key. First is the simple key. Simple key, we know it is attached with the primary circuit, and it is used for opening and closing the primary circuit. Then the short circuiting key. Short circuiting key, you see on the right hand side picture, it is attached in the secondary circuit, and it is connected parallel in secondary circuit and used for short circuiting the current normally flowing into the electrode. And it is kept closed to prevent the passage of current to the tissue. It is opened only when the excitable tissue to be stimulated, because we want to prevent any damage to the tissue. That is the reason we keep the short circuit secondary circuit in the short circuit position. Only when our experimental setup is ready, we will do what? We will make the simple key on and short circuit key off, so that if the primary circuit is closed, there will be current in the primary coil. That primary coil current will be induced into the secondary coil, and the current through the electrodes, it will be transferred to the skeletal muscle. Now this second short circuit key is kept opened or off position when the excitable tissue is to be stimulated. Okay, when we want to here when it is the short circuit key, it is closed, so no passage of current and the tissue damage is prevented. Another important instrument in this experimental setup is the tuning fork. It is a vibrating tuning fork of a frequency, of a specific frequency of 100 Hz, with a pointer attached to one of its prongs that is used, and it is employed to take the time tracing. You know that we take the time tracing in this way on the rotating drum. We just vibrate it and touch this vibrating tuning fork on this rotating drum, and we get a wave-like or undulating tracing like this, that is known as the time tracing. Why this is important? Because we want to count the duration of all these phases of SMT, that is latent phase, contraction phase and relaxation phase. Why we want to count? So if I want to if I increase the temperature, if I increase the frequency, is there any change in this duration of the phases? That is the reason. So if we don't know what is the duration of time in SMT, then it will not be we will not be able to interpret the results of other experiments. Okay, how can we count? We already know that tuning fork has a specific frequency of 100 cycle per second, or 100 CPS, or 100 Hertz. So we can say that 100 cycles per second, that means 100 cycles 1 second. So one cycle will be 1 by 100, that is 0.01. So the difference, the distance between one crest to another, it is 0.01 second. Okay, so when we will calculate the duration, so suppose in the contraction phase we have 4 crests. So 4 into 0.01, that is the 0.04 second is the duration. Okay, in this way we calculate the duration of the each phase of the SMT. Okay, for this reason we need this tuning fork of a specific frequency, that is 100 Hz or 100 cycles per second. Thank you.